All right. Now, when you're doing regular equations, and when I say regular equations, that means when it has an equal sign. When it has an equal sign, that means that you have one number that is the answer or the solution. Now, the only difference between these problems and the equals is that these problems, you're going to have more than one solution. Oh, there it is. There we go. Okay. Let me pull up. There. So this is x plus 7 is greater. But before we do that, I'm not going to do that. What I'm going to do is change it to a regular equation. X plus 7 is equal to 2. That's your regular equation. Now if I want to subtract 7, and that's x is equal to -5. That -5 means if I plug it in, -5 plus 7, that 2 is equal to 2. Is there any other number that will give us 2 is equal to 2? No. There is no other number. You can plug in -1/2, it won't work. You can plug in 5, it won't work. You can plug in -10, it won't work. This is the only number that will work in this equation. Does everybody understand that? Yeah. Okay. Now, that's when we have an equal sign. Now, we don't have an equal sign now. Now we have an inequality. And the inequality gives you a solution set. And a solution set is more than one number. So, we go here. Inequalities gives us more than one number. These two guys and these two guys. These two guys, whenever these two guys are involved, you're talking about an open circle or a set of parentheses. Okay? Whenever these two guys are involved, you're talking about a closed circle, one that's filled in, when you're graphing on a number line or whatever, and you're talking about brackets. This is inclusive. This is non-inclusive. Non-inclusive means that you cannot use a number. I'll get to that in just a minute. This is very important for you to memorize. If you don't memorize it, then you're going to come in Monday, and I'm going to do a problem, and you're going to say, well, why is it like that? And I'm going to look at you and I'll say, you did not memorize what I asked you to memorize Wednesday. Okay? So you need to take your handy-dandy highlighter, and you need to highlight this. Now, that last problem was x. What was it? X plus 7 equals 2. Or I don't want it equals. What did it say? X plus 7. Which way is the alligator eating? Did it have an inequality? Which way was it going? Huh? Okay, so it was this way? Equals 2 or greater than 2. That's what this says. This says x plus 7 is greater than 2. Now, if we lived in Saudi Arabia, we would say 2 is less than x plus 7. Why do I say x plus 7 is greater than 2? And if we lived in Saudi Arabia, it would be 2 is less than x plus 7. Why? Because we read left to right. Okay? I don't want anybody calling this greater than or less than because you don't know which way you're reading. So x plus 7 is greater than 2. So we solve. Same way we've been solving. And x is greater than -5. Now, if you don't know what this means that all of our numbers that will work in this equation is above -5. So, graph it. -5, 0, 0, 5. And what kind of problem do we have? We have one of these guys. So that means I use a what? An open circle on -5. Now what does that mean? I wish this thing would work instead of causing me heartache. That means that I cannot use 5. I can use every number, what? Greater than 5. Now this arrowhead over here is called positive what? Positive infinity. This arrowhead is called negative infinity. So, what numbers can I use in this equation? I can use all numbers from -5, not touching -5, to what? To infinity. Okay? So, pick a number from -5 to infinity. 100. Plug in 100. 100 plus 7 is 107. Is 107 greater than 2? Yes. How about 0? 0 plus 7? What is it?
A baby.
Oh. 0 plus 7? Probably somebody with the baby, I would hope. Because if the baby was by itself, it would still be hollering. So 0 plus 7 is greater than 2, so that would be 7 is greater than 2. How about 10? 10 plus 7. So what is the difference between what we did in 6.2 and what we're doing in 6.7, or whatever section we're in, 6.6? What's the difference? In 6.2, we had how many solutions? In 6.6, we have how many? We have a lot of solutions. It's called a solution set. You need to write that down. A solution set. Solution set. Now, what about 5? -5. Well, let's plug in -5. -5 plus 7 is what? Is 2 greater than 2?
No.
No, it's not. So you cannot use -5 in this equation. It would be untrue. That's why it's called what? Non-inclusive. And that's why you have an open circle or a parenthesis to establish, to tell the reader or to tell the person that's reading the problem that you cannot use what? You cannot use -5. That's what the open circle means, and that's what that parenthesis means. Well, why do you have a parenthesis on infinity? Well, just answer that question. Tell me what number infinity is. You don't know. You don't know what number it is. So you can never touch infinity. So you always put a parenthesis on any of the infinities. Okay? Now, there is one thing that I've been stressing to y'all in 6.2 or 6.3 whenever we learned how to solve equations. I stressed and I stressed and I stressed, and I said always keep the variable what? Pi itself, but always try to keep it what? Starts with a P. Positive. If you keep the variable positive, you won't run into problems with the inequality. If you do what I said not to do, if you went against the grain, then you're on your own when you're dealing with inequalities. Okay, because I've taught you the easy way to deal with inequalities. All right? So there's two people in here. There's one person that said, I'm going to do it that way because I don't have to fool with anything. I'm going to do what he says. And then there's the person that says, okay? The person that did all the growling and all the, you're on your own here. Because I showed the easy way to do it. Okay? So let's do one. Let's do one, and I'm going to make it up. That means that I'm trying to discourage you. So let's see what happens. Let's go with 2 times x minus 4 plus 3 is greater than or equal to 6x minus 2. Question, what's the first thing you're going to do? You're going to bust up the concrete block. Yes, with the 2. Good job. You at least listened to me that day. Bust up the block. You always bust up the block. Yeah, we went over that. You don't remember that? Busting up the block to get the ring?
I remember that.
Okay. As long as you remember it, that's all I care. All right, so bust up the block. What do you get? 2x. Good job. What's the most common mistake students make? They forget to what? They forget to distribute with both. And that's why I always tell y'all to use the arrows. Plus 3 is greater than or equal to 6x minus 2. Now, whenever you use the distributive law, put DL right here. Whenever you use the distributive law, what is usually the next thing that takes place after the distributive law? C, L, T. Combine like terms. Good. And you need to remember that because that is usually what happens, I don't care if you're in second semester calculus, if you distribute anything, the next step is probably going to be combined like terms. So, the only like terms that we can combine are -8 and +3. You owe $8, you have $3. What's the outcome? You still owe 5. Greater than or equal to 6x minus 2. Yes.
Usually we change it by itself, or well, on equal, but I added 2 in here this time.
Where?
Usually we added 2.
This? Yeah, tell me what you're talking about.
Before you circle the 8 and 3.
Right here?
My next, you combine that whole stuff.
Well, you can't do this one yet because it's on the other side. You mean you could bring it over here if you wanted to and make it add to. That's fine. You can do that. But I'm doing it step by step. So, but that's fine. You can do that. That would be -5 plus 2 is a -3. So you should get a -3. That's what you should get.
Okay, I added 2 on there, 1, 2, and 3, and I added 2 there.
All right, what's -8 plus 3?
I didn't get that.
Well, you should get that because 2 times -4 is -8.
No, I didn't circle those 2. I just went straight and did the first 2.
Okay, well, what I'm saying is if you take -8 plus 3 and you add 2, if you bring that over here and add 2, you should get -8 plus 5 is -3. That's what you should get, no matter what. No matter how you do it, you're going to get plus 3 right here, -3. Huh?
I just didn't get that from you. I was just asking, can you add 2 there?
Yes.
2 and 3, you get +5.
Yes, you can bring this over here and get +5, yes. You can. But when you do the -8 plus 5, you're going to get -3. Okay, that's fine. Now, which one's the smallest bucket? The 2x or the 6x?
The 2x.
So you're going to bring the 2x over. Now, we've already discussed that. I'm not going to go back through that again. But we discussed that over and over. Everybody uses the smallest bucket. And when it comes across the river, it turns into what? -2x. Now, the reason I'm taking it to the right side is because I want to keep the variable positive. If I keep the variable positive, I don't have to worry about 2 or 3 other steps with the inequalities. So now I get -5 is greater than or equal to 4x minus 2. Now we have the x on the right hand side, so that means we got to get rid of a -2. How do you get rid of a -2? Well, you either add 2 or you take it across the river. I'm going to take it across the river and it becomes a what? +2. So now we got -3 is greater than or equal to 4x. Finish it out. Now, when I say finish it out, I want you to also graph it on a number line.
Okay, so we got the same answer. I just did it the way that I used it.
I hope that 4 is positive. I hope this 4x is positive. Is it? Okay. No, I just want it to be, yeah, you want to, yeah. Divide by 4. So x is less than or equal to -3/4, or -3/4 is what? Greater than or equal to x. So I'm going to draw my number line. There's my number line. This is 0. This is -1. And this is +1. Now what are we dealing with? Negative what? Negative 3/4, which is right in here. I don't care where you put it. This is about a half. 3/4 will be right in here. I don't care where you put it, but I'm going to put a red line or a red what? What kind of circle goes at 3/4? A closed circle or a full circle. Why is it full? Because the inequality has a what on the bottom of it? Has an equal sign. That's why it's red. That's why it's full. So if you'll make it bigger, you can make it bigger. There, made it bigger. All right, now, what numbers are less, because X means the numbers, which numbers are less than negative 3/4? Because remember, negative, the further you are away, the more smaller you are. So which way is X less than? Huh? Left. So you take your handy dandy red marker, highlighter, and you shade this way. Now what's this guy called? He's called negative what? Negative infinity. So if I wanted to write this in interval notation, and that's what it's called, I would put a parenthesis. I would say negative 3/4 or negative infinity, sorry, comma, negative 3/4. What goes on negative 3/4? What goes on negative 3/4? I put a parenthesis on infinity. What? A bracket. Good. And why a bracket? Because it's inclusive. So I take my handy dandy highlighter. That's why you got to memorize that when you have an equal sign here, you have a closed circle, which means that you have a bracket. Yep. That's called interval. Write that down. That's called interval notation. Interval notation. The other one's called set builder notation, and I'll show you that. It's not a big deal.
So all these are solutions, underline, the interval notation, the equations.
Well, it all depends on what they ask you. Some of them just going to ask you this, and they'll just say X is greater than or X is less than or whatever. Okay? Then some may tell you to graph. And then some may tell you to write it in interval notation. Some may tell you set builder notation. And I'll show you set builder in just a minute. Alright, so let's try nerd.
So every time it's going to the left, you're going to put one pencil, one right.
Not every time it's going to the left. Go back. What did I tell you? Go back. Right here. If it's these two guys,
Yeah, no, I got that.
okay, well, what are you asking?
Why do you only put one pencil in one right?
Because parentheses, infinity always gets what? It always gets a parenthesis because you can't touch infinity. It always gets parentheses. And what did we have in that one? What's this? Infinity. So it got parentheses. The only time you're going to have brackets is when you have two numbers. Two brackets, you're going to have two numbers. And we're not going to worry about that right now. I don't think we'll have any of those. We might. I don't know. So let's go with negative 3 times x minus 2 is less than 4 times x minus 6, x plus 6. A little easier.
you keep the subtraction right here, or do you keep the subtraction once it turns positive or
It's negative times a negative.
positive? So what do you
Put a positive right there.
Oh,
That's it.
that's no, I never had to do that.
That's all right. These people get me. They act like they haven't heard anything about pre-advising. They just, I was just wondering when I can come by and get advised. Like they have no clue. All right. So that's going to be negative 3x plus 6 less than 4x plus what? Now that 3x is going to come across the river. And that 24 is going to come what? Across the river. No, you wasn't. No, you wasn't. You're wrong. You're going to get it wrong. 7x is greater than negative, you have $6 in your pocket. You owe 24, so you still got to owe what? And divide by 7. So x is greater than negative 18/7. Now, if you have to change it into a mixed number to graph it, that's fine. But I would leave it as 18/7 and just change it in your head. Well, 2 times 7 is what? 14. So 4/7 is a half. So that's what? 2.5? Negative 2.5. So, oh, well, it's not really to be quiet. This is just for graphing, okay? You're not counting ounces of gold. So I'm going to take my handy dandy straight line maker. There's my straight line. And you can number it however you want to. I don't really care about that. So 0, 1, 2, 3, negative 1, negative 2, negative 3. Now, we've already said that negative 18/7 is about negative 2.5. So I'm going to take my handy dandy circle maker, divide 7 into 18. That'll be 14 and 4/7. And 14 and 4/7 is just like 4/8, which is a half. So 2.5 is where? Right here. What y'all talking about back here? Can't take nobody nowhere. All right. There's your open circle. I'm not going to be able to. No, I can't erase it because it's too big. So anyway, there's my circle. So I'm going to take my handy dandy highlighter. And what numbers are greater than negative 2.5? Everything to the right. And what is that right hand arrowhead called? It's called positive infinity. So if we wanted to write this in interval notation, it would be negative 18/7, comma, infinity. And what always goes on infinity? Parentheses. And what will go on this guy? Nope. Why parentheses? Because it doesn't have a line under it. Now, what is set notation? Well, set notation is real easy. All you got to remember is braces. And put an X such that. Okay? Braces, X, and then a line. That means such that. And then take your answer right here and put it right here. X is greater than negative 18/7. And that's called set builder notation. Set builder notation. This is called interval notation. Which one's used the most? Interval notation is used the most with algebra teachers, at least with me. Okay? It might. I don't know. You just need to learn both of them. Okay?
Is it always going to look like that?
It's always going to look like this. Your answer right here comes from here. Now the reason, why did I put X first? It's because traditionally we read from left to right and X comes first. You don't have to write it like that. You could say negative 18/7 is less than X. It's not mathematically incorrect. And anybody that does mark it incorrect is really wrong, because there is no reason that you can't leave your answer like this in here. Okay? But traditionally, we got the math teachers back in elementary school that told you had to put the X on the left-hand side. It's like telling your son that he has to sit on the left-hand side of the seesaw and he can't move to the right-hand side. Okay? All right, let's do a nerd. Since it's going to make up pretty much 50% of your test, or 40%. So let's throw a variable in there so we can really throw you off the rails. 1/3 times X minus 7, clear the fraction first, plus 3/2 is less than or equal to 2 times 4x minus 7.
What do you call that squiggly bracket?
It's called a brace. I can't draw a brace like real good, but there's three kinds of external notations you can use. One is a parenthesis, one is a bracket, and the other one I can't draw very well is braces. And braces, mine always look like Bob Hope. I can't draw braces. Some of y'all draw them real pretty. I can't draw them. So, and that's after 20 years of trying. I've tried and I've tried and I've tried, and I've just come to the conclusion that I can't. I just suck at it. Yeah. So I live in a ditch. When it comes to these guys, I live in a ditch and drink too much. Because I want you to be able to leave this classroom and be able to not look stupid when you see a fraction. Orb of silence, and you're not gonna pass class unless you know how to do fractions. But you clear them. You just get rid of them. Multiply through by what? 6.
But do you do it on the other side too, or you do it on the first side?
If you do it on one side, do it on the other.
Okay.
Can you put your hand in the concrete block? No, you cannot. You can't multiply that 6 times 4x unless you use distributive law.
Where'd you get 6? As a common denominator.
Y'all aren't listening to a word I'm saying. Clear the fraction. You are. Say what? Okay, let's do it the hard way. Y'all want to do it the hard way? We'll do it the hard way. Y'all keep pushing, so we're gonna do it the hard way.
That was a joke. That was a joke.
We're gonna do it the hard way.
Oh my God.
Okay, y'all ready to do it the easy way?
Yes.
Okay, we're gonna multiply through by 6 over 1. 6 over 1, and that 2 is over 1. So 6 divided by 3 is 2. That gives us x minus 7. Oh, we gotta also multiply by this guy, because he's not in parentheses, so he's touchable. So 6, what is it, 9?
Yes.
Less than or equal to 12 times 4x minus 7. Now, wouldn't you rather work with this than work with this?
Yes.
Okay. So get rid of them. And don't you dare ask a question because you were on your phone. You were on your what? You were what? You are about to get ready to get thrown out of this class. I have shown you how to do this over and over. And you are piddling with decimals. You don't have to. No, I'm mad. What? What's your question? Huh?
When you find the common denominator of 3, 2, the fraction 3, 2. Okay.
They're both prime. So what do you do when they're prime? Multiply them together. What if this was a 2 and this was a 4? You multiply by 4. What if this was a 2 and this was a 7? You multiply by 14. What if this was a 2 and this was an 8? You multiply by 8. Now multiply through.
2x. 2x minus 14.
Minus 14.
Plus 9.
Plus 9. 48.
Minus 84.
Good gracious, y'all actually doing this stuff. Well, I'm going to have to get some more problems up here. I'm going to have to figure out a way to discourage y'all. Negative 14 plus 9 is what? Now, finish it. You should be able to finish it now. Now, if you can't find, remember, what do you do if you can't find the common denominator? What do? You go over here and you write what we learned in chapter 1. What will go into those 2? 2, that'll be a 1, 3 come down. 2, 1, and 1. I'm sorry, 3. And what's 2 times 3? 2 times 3 is what? 6. Or you can just remember that if the 2 prime numbers are prime, multiply through by 6. That's it. And you clear the fraction. Yes?
Instead of it being plus 3 like a fraction.
Where?
Okay, in the first, it says 1/3 x minus 7 plus 3 over 2. What if there wasn't a fraction? What would you find the common denominator?
Well, okay, then I don't want to like mix numbers here, but if this was a 6, let's say this was a 6. It'd be 6 over 1. So what's the common denominator of 1 and 2? 2, so you multiply through by 2.
Okay. So if it was just 1 over 3, I would multiply by 3.
If this was just a 4 or something,
yeah,
then you would just multiply by 3 all the way across.
okay.
Whatever the denominators tell you, that's what you multiply through by. Okay? Now, which one's the smallest bucket?
2.
Minus 2x. And that gives us negative 5 less than or equal to 46x minus 84.
I got to use the mouse because it won't work right if I don't use the mouse. Really? Hold on. There. Now. There. All right, now. Bring the 84, what? Bring the negative 84 across the river. And you owe $5, you have 84. So if you owe somebody $5 and you have 84 in your pocket, then you got 79 what? Or 70 what? 80?
79.
79? And divide by
26.
so X is equal to about what? Let's see, 79. 46 times 2 is what? That'd be 92. So that's 80. So you're less than 2. I'm sorry. It's 1.8 or something like that. Again, do we really care about the numbers as far as it being, you know, a mixed number? No, because what are you doing? You're locating. So this is the answer. But as far as locating, that's probably 1.8 or something. Somebody punch it in your calculator now.
1.7.
And it's 1 point what?
7.
1.7. Okay, I'm off a little bit. So I'm a loser. So that'd be negative 1, negative 2, 1, 2. Now, what kind of circle are we going to have? Closed. So 1.8 or 1.7, take that guy and you put it right about there. Now, what does it say? It says that X is what? Greater than. So you take your handy dandy highlighter. Hold on a minute. I got to go through the Act of Congress up here. Thank you. Now it's not going to work.
It works.
Be so nice to have training on something that they give us. Not wanting much, you know, just wanting training. That's all. Not much. There. So this number is right here. Okay, now how do you write that? I'm not going to worry about set builder notation. But interval notation, we start at what? 79.46. 79. 79.46. And we go to what? Infinity. What always goes on infinity? And what goes on this guy? Right. And that's your answer. That's your location. Okay? So let's try nerding. Let's go with 1/2 times x minus 4 plus 2/3 is greater than or equal to negative 1/4 times x minus 2. All right, do that one. Now, right quick, 2 and 3 is prime, right? But that 4 throws a little bit of a monkey wrench in it. What's 4 times 3? 12. So if you multiply through by 12, you should be all right. Or you could say to yourself, well, 3 times 4 is 12, and 2 will go into 12, so I can multiply through by 12. And when you do that, you should be able to clear the fraction. So I'm going to put a 12 here. And I'm going to put a 12 here. And I'm going to put a 12 here. Now finish it. What was that?
This is Anderson Campus Director Tim Bowen, and this is a test of the emergency paging system at Anderson Campus. Were this a real emergency, we would be providing you with important information about the situation and what to do. However, this is only a test. Thank you and have a great day.
Where'd that come from?
Come from the phone. In case we have some crazy person come in here with a gun. Well, they'll fire or anything. Well, it's kind of important to do. I mean, now you got crazy people out there.
You always have.
Well, we've always had them. It's just now they're just even crazier. All right, what's 12 divided by 2? 6. And what's 12 times 2 divided by 3?
8.
And then what is 12 divided by 4?
3.
All right, now finish it. The whole point is there anything different as far as the mechanics of 6.6 and 6.2? No. The only difference is that you're going to have to rewrite your answer differently or locate it based on the inequality. The mechanics are the same that you learned in 6.2. So distribute
6x
minus
24
plus
3x
less than or equal to or greater than or equal to negative 3x plus
plus 6.
combine like terms, 6x. You owe $24, you have 8. So you give the person the $8, you still owe them what?
16.
Negative 3x plus 6. Now, which one's the smallest bucket?
3.
The 3 is the smallest bucket, so you bring it across the river. And that becomes a plus what? 3x. And that's going to be 9x minus 16 is less than or equal to 6. Bring that 16 across the river, and it becomes a positive 16. And that's going to be 9x is greater than 20 what? 22. And then x is greater than or equal to 22 over 9. which is what? 9 would be 18 and 3/9, which is 1/3. So it's a little bit over 2. A little bit over 2 and 1/3. Okay? No yawning. All right. Now, there's one other problem. We're really 2 other problems I need to show you. And that's because they are probably going to be on your test, and you might need to make a note of them, okay? And I don't really, not a big fan of them. So, one of them, it's going to ask you, and it's going to have in the directions, it's going to have integers. What are integers? Whole numbers. Now, the reason it makes a difference is in the graphing. So, if you have, I'm going to just make up one, x, minus 3 is greater than or equal to 2x plus 7. Okay? And bring the x across, that becomes an x. Bring the 7 across, that becomes a negative 10. And there's your answer. Now, that's not different. But what's different is since you've got this guy right here, and since integers mean what? Whole numbers, when you graph it, well, that's not what I want. There. When you graph it, you can't graph the fractions. You can't graph the decimals. Okay? You have to graph just the what? So I'm going to put a 5 here, and I'm going to put a negative 5 here. And you can put 1, 2, 3, whatever you want to. Depends on what kind of graph they give you. So I'm going to take my blue marker, and what does this mean? That means that I'm going to use what kind? I'm going to use solids. But my numbers have to be less than what? Negative 10. So, well, I went the wrong way. Hold on a second. Negative 15. Negative 20. No hiccups either. Negative 25. Okay, so now I'm going to take my since it's integers, since it's wholes, I can't do in between. So I have to do inclusive. Can I use negative 10? Yes, because it's inclusive. And then I'm going to put a dot here, and a dot here, and a dot here. I cannot shade it because I can't include fractions and decimals because it's a what? It's whole numbers. It's integers. The question is asking for integers. So be careful. You're going to have a couple. I don't know if they're on your test or your homework, but you're going to have a couple that just ask for you to graph the integers. Okay? And the last problem I want to show you is one that you're not going to be able to get away from the negative exponent. And it looks like this. Negative 7 less than x, negative x, less than negative 5. Okay, now they're going to ask you to solve this one, and there's nothing you can do to get that variable positive. The only thing you can do to get that variable positive is divide through by what? -1. Now here's the rule that I've been trying to avoid teaching y'all, because I don't want you to keep the variable negative. I want you to keep the variable positive. You have to remember, that's one thing you have to remember, to divide through by negative. Then you have to remember, after you do that, you have to what? Flip the what? The inequality. And that's two rules that you have to remember if you don't keep the variable what? Positive. Okay? All right, so now you are responsible for 6.1 through 6.6. We will look at the test on 6.6 when y'all come in Monday. Okay? All right, y'all have a good day. Jan, come here. Jan.